we are going to explore about how IoT technologies are usable in modern farmers in agriculture field, and the design thinking approach gives an impactful and sustainable solution for modern agriculture. So for this, we are going to analyze this case study based on design thinking in stage by stage. The first stage of this case study is empathize part, and the empathize part will be explained by Samutika.
Yes, the empathize stage begins with observing the user needs. So in this case, it's farmers. So understanding their challenges, environments and limitations. So through some field visits and some interviews, we come to know that there are a lot of problems in the farmers in the agriculture practices. And let me list down one by one. First is unpredictable weather condition. So due to this, farmers struggle to find the right time for their crop production and yield productions. Next comes the water supply, because mostly large amount of water is being wasted due to the manual practices. So as to reduce that, a smart system is being needed. Next comes the diseases of crops. Mostly farmers found the diseases too late, so which leads to reduction in crop production. So from these all observations, it shows that farmers need a device or a system that works efficiently and reliably to them.
So from this empathize part, we know that so many problems are available in farmers field. So from that, we are going to define the problem in next stage.
So the define stage, crafting the problem statement. So from insights gathered, so we clearly defines the centered problem. So the problem statement is, how might we help farmers to monitor the crop conditions and irrigation system, temperature, humidity, etc. So to solve this, there are some specific conditions must be addressed. So the solution must to provide farmers to monitor the humidity, temperature, and irrigation system. So it must work even in limited connectivity areas, and it must want to give timing a lot to avoid over irrigation system, and this are the different stage.
So after defining, we know that in agriculture field we are using so many sensors for conditional monitoring and for alarming systems and IoT enabling technologies, so we have to select. So for this, we move on to the ideate stage of this design thinking case study. So can you explain about the ideate stage?
Ideate stage, we have discussed several creative ideas to solve the farmers' real-time problems. So some of our ideas are an automated irrigation system which uses soil sensors to control water flow. And the second idea is the climate monitoring, which monitors the weather like rainfall, humidity and temperature. And the third idea is crop monitoring, which uses drones and cameras to monitor the crops and prevent them sick. And our fourth idea is IoT based fertilizer system. And our fifth idea is mobile app dashboard. This app gives farmers the real-time alerts and graphs and advices in their own language. So by comparing all these ideas and considering the cost, use and the farmer's convenience, we have designed a smart agriculture IoT system based on all these ideas.
So coming to the conclusion from the ideate stage, we are going to develop a prototype for smart agriculture monitoring. So can you explain about the smart agriculture monitoring with a small block diagram?
To demonstrate a prototype of smart agriculture on using an IoT, we have a total 5 steps. First is that sensor. We have a moisture sensor, humidity sensor, temperature sensor and a motion sensor. And then second step is a microcontroller which max 232 collects the data information and it gives up products. And then third is connectivity. We are connecting that Wi-Fi to the Arduino board and then the clouds. And then our fourth step is a cloud platform. It shows the real-time graph that turns an trigger alert, and a MQTT is used to publish a messaging from device to the cloud. And then our fifth step is connections and then automations. In our first is to turn on a irrigation pump, and then second is trigger air purification, and then fourth we are connecting adjusting a lighting, and then fifth is sending mobile notifications. So these are the prototypes we are using real world application in agriculture.
So coming to this, the smart agriculture using IOT, the first step is to sensing the physical data that is available in the farmer's field, and then the physical data are transferred to the microprocessor or microcontroller boards, and then the processing data will be stored in the cloud storage. So based on our storage data and the present data, it will compare the original data, and then it will give a message or alarm to the agriculture or farmer. So based on that, the IoT system will turn on the water or turn off the water. So from this ideation and prototype, we are coming to the testing stage is the next one. So can you explain about the testing stage?
So evaluating the solution in the real farm conditions. So this prototype was being tested for 2 months in the real farm. So that results in water saved to the percentage of 35 to 40 with the automated irrigations, and it also crop yield will be increased to the percentage of 15 to 20 with a good moisture control, and also the labor requirement will be reduced, so no manual check for the soil is being needed, and also the real-time alerts. So it helped to take a quick decision when there is a weather change, and it also gives the high user friendly because the farmer found it very simple and useful. And also the feedback from the user is it is a local language app, and it is a easy sensor setup, and it has a strong connectivity, and also it gives the weather alerts.
So now moving to the conclusion part of this case study. So can you give a smart conclusion about this case study?
Yes, sure. So coming to the conclusion, so with these research, observations and testing, it shows that our solution, that is smart agriculture using IoT, meet all the needs of the farmers and we build a better system for the future.
Thank you all.
Thank you.